Welcome, part 24. Today we will continue working on the switch wire. But unfortunately, all the parts I really need are still at the customs or like in shipping. So today I think we'll just debug a bit. We had some problems last time. For example, the toolhead LDs don't work at the moment. And generally it's not printing super well yet. I didn't do a lot since last stream. Basically all I did is just I worked on the sensorless homing a bit. I made it a little bit more sensitive because less sensitive because I had some homing failures. So basically the y-axis didn't quite move all the way back and stuff like that. So I fixed that. So it's homing now like reliably, which I think is really important. And besides that, I made one more change. The X and Y steppers. The X and Y steppers, or like before, all three steppers were running in Stealth Job. That basically makes the steppers less noisy. Makes it less noisy, but also like costs a lot of torque. And last time we had really bad results in the in the input shaper calibration. And I just run the shaper again and was kind of fixed. So basically what happened, or like the shaper numbers then were like around 5,000 for X, but Y only had 3,000 millimeters per second squared. So basically I leave these two running in Stealth Job. That basically gives us like, around, I think like 5,100 millimeters per second squared. But Y is now running in spread cycle. So spread cycle basically just means it's noisier, but at the same time, it's having way more, the stepper has way more torque. And basically with the spread cycle, instead of Stealth Job, I went from 3,000 millimeters per second squared to 5,000 as well on Y. So basically now I can just use 5,000 as maximum acceleration. And like all the axes kind of matched that, which is really cool. So it's like very even. I did some printing. And smart as I am, I don't have the test cube here. I thought I forgot that. But basically I think the extrusion was very uneven. It was just like not like nice layers basically. So we need to figure it out today. But first I want to quickly work on the tool headlights, just see like what's up there. Then I think we just like start printing, calibrating a bit, and trying to troubleshoot the issues. So let's start with the tool headlights, I guess. I'm not quite sure yet if it's a hardware issue or if it's a software issue. Because like they were working at one point, so I'm really confused why they suddenly don't work anymore. So problem basically is if we set any color to tool headlight, I would expect this to turn on. But that's not the case. And it's a bit hard to debug, I think. So I think what we should do is most likely just shut it down, take off the front plate, and just first make sure that electronically everything is correct, so like the plug isn't loose or something. And then, just work from there. Let's see. I hope that's not like a serious issue in any way, shape, or form. And just some minor annoyance. I'm also not quite sure like how to check that properly, to be honest. So yes, we can now check for power. For power, we can check easily. But I'm not quite sure. And you could also, now it's off, but I think it's also good to just double check the configuration. And just make sure that we have the right pin and nothing changed. Although again, like they used to work, I think. Here it comes off. Just dump all the screws. Just move that back a bit. Okay, so the bottom plug are the LEDs. So think what we can do is we can just like check that the connection from the back of the plug here to somewhere on the LED is correct. That we just get the continuity there, that we know that the plug is okay. So let's just start with the red one. So we have continuity from the back to here. Yeah, and if I touch this here in front, I also get continuity. Let's try the round one. Yeah, I also get continuity on ground, so power should be fine. Yeah, the yellow one is a bit difficult to probe. I'm fairly certain that, I guess if two are fine. I can also quickly like remove this from the housing. Makes There's no continuity on the data. Oh, sorry, no, it's actually leaning forward. So this one, from back to middle, we have continuity, but from here to here we don't. So it seems like something is not correct with the plug here. Especially on the data line. Which is weird. And I'm not quite sure what could go on there that doesn't have continuity. I mean, you can just recrimp the plug, which is really odd. Okay, but I guess we at least found the issue. Sorry, I'm constantly leaning forward. Let me just show you from a bit of an angle. Maybe let's try to get this out first and look at the crimp itself, if we see something there. That will most likely be the end of the housing. Yeah, it looks like a crimp, so I'm not quite sure if there's something preventing me from measuring continuity there. Oh, of course. The yellow cable first goes to the center LED, and then basically goes in the LD and the other side out. So that's why we don't get continuity. So I'm pretty sure that's not the problem. I mean, now we kind of destroyed the plug, so that's... I guess we have to replace the housing now. Okay, but... let's replace it quickly. Now I feel bad for needlessly destroying this very beautiful housing. Oh, let's just grab a fresh one. Just pay attention that we do it in the right order. So red on top. So I have to convince them to go back in. I don't use the proper crimping pliers for DuPont connectors. So my crimps are always like a bit on the thicker side. Makes it a bit challenging to convince the cables to go into the housing. And collect on the bottom. Okay. Then the connector's patched up. The red one is a bit odd. Convince it a bit more. Okay, so the red one is now a bit odd. Can't quite push it all the way in. That's okay. It's not like the other one here as well. Like I can't quite push to the front. There's like something. Just quickly check that we have good. Okay. Should be fine. Okay. So then the next question is if this is okay. So I just assume that the connector here is okay. What else could it be? So the connection looks good. Now it's assumed, like, I mean, this block should be fine too, right? It's unlikely that the fans work and everything works, only the LEDs don't work, and it's like something like in front of that, like before the connector basically. So let's just put this back on. Make sure that we have it like properly aligned. It's like one of those things like I'm really afraid of like misaligning those pins. They're like really easy to misalign. Yep, it's wrong. So long goes on the bottom, of course. And then I would say let's just double check the configuration and see if we find something there. Also just checking because like my print quality wasn't quite okay. If the hot end is a bit loose, it looks kind of okay. Okay. Let's check the configuration if we see something there. So just double check, it still doesn't work. Still doesn't work. Then we look at the toolhead lights, which is this one here. So we have GRB, it shouldn't have changed. So the only thing that really changed maybe is the EBB GPO16. So let's just double check SBB SB2209 pin out. I'm not quite sure if this is the correct one, because we have the SB2209 2040. Ah, here it is. Let's see. So this is the 20. This is the correct folder. And then we have the sample config here. Let's see. So we have, yeah, GPIO 16, hotend RGB. But this matches what we have here, right? GPIO 16. It's just like for me the things called differently. That's really the only thing that doesn't work, right? So if we, I mean, the hotend fan works. Let's just quickly double check that. Yeah, that works. The new fan I put in, like, is really silent and it's not really strong, so it's, I mean, it's good it's silent, but it's not good it's not strong. So the fan works. Yeah, it's also like the underglow I have works. So it's not like a general RGB issue. So you can't see it here. There's like a yellow shine there. So that works. So it's really only this RGB. Curious. I'm not quite sure if we could have broken something there at some point. Because there's not much to it, right? It's only the GPIO 16, which is configured. We did configure chain count, but I mean, let's just go with the exact example they have here. Let's just copy this over. Because I also configured the color order, which, I mean, I think is correct because that's the colors we have. It could also just be that like one of the LEDs is defective. Like if the center LED is defective, the first one, all the other LEDs won't work either. So it's also potentially an issue. Oh, I forgot to change. This is just called EBB for me. I'm fairly certain that that makes no difference. Nope. I don't know, like I mean, there are two options, right? It's either that the toolhead board is broken on this one pin, like everything else works perfectly, but this one pin is broken somehow. That's an option. And the other option is that one of the LEDs is defective, like, or one specifically the center LED is defective. I wonder what we can do is, because I have tons of LEDs here. Not here, but over there. Let me quickly just grab some LED, and we just create a small test LED that we can plug into the toolhead board, because then we know if it's really the LEDs that are defective or whether the toolhead board is defective, and we can at least like eliminate one variable. The other option would be to plug the LEDs in something else, but I think it's easier to just have an LDO toolhead board. Let's quickly do that. I'll grab the stuff. I'm back in like 30 seconds, and then we just try it out. It's easier. Right back. Okay, lots of LEDs. I'll just maybe we can just use this like short strip here and just snap those off. Maybe we can even get away without soldering. I mean, it's really short. Let's solder some longer wires here, and then I have a lot of those like high density LEDs here. I didn't remember I had so many of them. Trick. Strange that these only worked when it was on the 5V USB power and not worked since. Did we have it on 5V USB power at some point? I can't remember. I only remember the LEDs were working at some point. Like I remember seeing them on. That's the only thing I remember. But yes, now I don't know, like the connector seems okay. Everything else on the toolhead board seems okay. So my best guess is really that like the center LED is defective. That's really like the only thing I can come up with. So let's put it just to the test and see if that really is the case. So if now the LEDs turn on with this like sample strip here, then we know at least what is defective. Then we know that like the LED for some reason is bad. Not quite sure how I would have managed that, but yeah, at least we don't know. Could we sort this? I really need to get like a better storage for these cable rolls. Like this box is horrible. Okay. Quickly. When flashing it. Did it work when we were on the 5V USB power? I mean, something we can easily try, right? Let's quickly do this, because I just have it like ready now. But maybe you're right, Steve. And like when flashing, we had, yes, we had 5V USB power on there. But that could also be like an explanation, right? So then that would mean that the board can no longer produce 5 volts because that's the only thing. The BLTouch also uses 5 volts. So I think then the BLTouch also should not work. Let's just use the same colors. Oh, let me grab some. But maybe the BLTouch uses a different 5 volt source than the LDs. That could also be the case. Up on the ground. Center one. Yeah, let me quickly pretend this a bit. It's also for I want to save time by not pretending. And in the end, you do it anyways. Okay, that should be fine. Let's quickly crimp them. I also have to order new pond connectors. I'm almost out. Let's see. One. Two. Three. Okay. Housing for those. And it was red and then yellow in the middle. And black in the middle. Let me already shut down the machine. So. And last one. Cool. Okay, that's our little test connector. Oh. Let me quickly close the window. It's a bit noisy. Right back. Okay, that's better. So, printer's off. Let's see. I'm really curious to see if this works. And then the next one would be, yeah, try the 5-volt USB. And we just have to set this the jumper. I mean, the thing is, like, just say 5-volt. Like, next stream I want to convert to CAN bus and remove the USB cable. Otherwise, I just want to say, like, we can just leave the 5-volt power connector, like the 5-volt jumper on. So let's just remove the plug here. Let's just double check. Yeah, it's the same. Oh, sorry. It's the same pinout. We did correctly. So let's just put this on and then just press this on. I think I'll just put like one security screw in just to prevent this from coming loose. Yeah, it doesn't quite. The plug in here like caused like a massive gap. I'm not sure. I think if we put it here, it should be fine. So you just have to kind of like find. Yeah, like this, okay. And let's put in the screw here. Hold this on. And yeah, that seems to work. Now, let's see if we can control those LEDs. Let's give this like a hot second to start up. Yeah, it's not sticky anymore. Moment of truth. No LED. Okay, that means it's not the LEDs we have in the toolhead. Not sure if that's a good sign. I would have preferred just the LEDs to be effective. That would have been easy to replace them and cheap. Then let's try the 5-volt power. First, undo our hack here. Such a shame. Now our entire like LED strip making was completely pointless. I still only put one screw in for now. I kind of see us having to open this again. Okay. Let's those way. Okay, we quickly have to check where I actually put the jumpers. Yeah, so here's the little jumper we have to set. And it's these two here. Yeah, where did I put the box with all the jumpers? Because these are like super tiny, like these are not the normal jumpers. I have tons of normal jumpers here. Nope. Okay. Yeah, I'm well prepared as always. I guess I'm gonna put the box back. Okay, let me quickly get the box. Sorry, right back. Here we go. I did not expect to use this again. Here we have a tiny jumper. That was already no fun the first time. I really didn't look forward putting jumpers on this again. Is it on? As always, like, camera has a much better view than I actually. Okay, so that's on. So now we have USB power. Okay, let's see what happens if we now turn it on. No lights. So it's also not a 5-volt power. Then I'm not sure what it could be. So we know it's not the LD, so it must be something with the board. We're not sure because we didn't change anything besides that. Like we added the jumpers for the fans, of course. And we can try to unplug the jumpers, but then the fans won't work, so that's kind of like pointless. If I have to choose between fans and LEDs, I go for fans. Blown the 5 line to the LDs when you didn't have it set right, that stopped the Nomi at first. Potentially. Yeah, potentially this happened. But then again, like the BLTouch also uses 5 volt. I don't think there's more than one regulator on here. Now we could check. You could check if 5 volts get to the LEDs. It's just like really difficult to measure, I think. Because you would need to measure it on the small plug, and that's like really annoying to measure. Like I don't want to like use a multimeter to poke around in that plug because it's can only go wrong. Okay, but then let's remove the jumper for now. I also need to quickly check my iPhone isn't charging. This is my iPhone camera. So we are at 20%. But for some reason, this is not really cooperative today. Let me quickly see. Now it's charging, okay. I just plugged it out and plugged it in back again. Okay. I have to keep an eye on the battery level there. One of you still getting 5 volt on the can in the subboard. Yes. Let's see. I mean, if you want to measure this, we have to measure it here, right? Like we have to measure it on this plug. We can't measure it here, unfortunately. Let's also first, let me quickly pull that jumper before we forget that. Okay, jumper's out. Like these are like so tiny. I mean, there must be 5 volt because the probe is working. The BLTouch is 5 volt for sure. So, I mean, let's first quickly check the pin out here, how that is built up. Let's see. So looking at this, it's smack in the middle. Nah, this will be really annoying to measure. So it's the 4th pin from the top. 1, 2, 3, 4th pin from the top. But even if you would have set this like off by 1, right? Then it would have gone on the can, which isn't connected, or it would have gone on the, I can't remember in which direction we misplugged that. Would have gone on the fan. And if it was plugged sideways, it would have gone on GPIO. So I don't see how that 5 volt could have caused trouble if it's like off. BLTouch doesn't get power from the faceplate. Yeah, it's true, but do you think like there's like two 5 volt lines, one for the BLTouch and one for the faceplate? I don't have those like little hooks for the multimeter. It will make measuring really difficult because if I I can do it. I just need to be really careful. So it's the 4th from the top on this side here. So it's 1, 2, 3, 4. Yeah, it should not slip there. Okay. I can use a DuPont wire, it's actually also a good one. If I have a DuPont wire laying around. which I have for sure somewhere. Let me grab the front wires. That's better safe than sorry. Right back. I'm just not sure if the quad fits on here because it's like the problem is this is like a different pitch. Might just work. Okay, let's see. So it's 1, 2, 3, 4. And then we just grab the ground from top. And that's just quickly organize that. 1 second. Okay. This looks good. Let's see. So then we should have 5 volts. It has 5 volts. This gives 5 volts. I mean, you can't see the display, but 4.9994. So that should be fine. So it's 5 volts. That would basically leave GPIO 16. Yeah, GPIO 16. I mean, we can try and plug in the LDs to a different GPIO port. We can also try to measure the GPIO port, actually. It's the third from the bottom. So let me just plug this in here and to ground, I guess. And what we do is we just set the... Yeah, it should be third from the bottom. So we just configure the GPIO pin 16 quickly as the output pin. Then we can set it to like high-low. Then we can just quickly check if we get 5 volts or something on that pin. I'm just not sure like if we can destroy like a single GPIO pin. Still booting up. So let's just configure this as output pin, I think. think it's just output pin. Yeah, output pin. So we just call this output pin test. And then we should just like be able to toggle it on and off. Test, yeah. So test is off, test is on. So let's quickly check that we now have 5 volts across the two pins here. .3 volts. That also works. It's 3.3 volts across the 2 pins now. Let me turn it off. Now it's 0. So, I mean, that kind of seems to work as well. Now 3.3 volts. So we have power. The I/O pin works. I'm not quite sure if I'm missing something super obvious here. Yeah, like we commented it out. Because like you can't use the same pin twice. So basically, if I put this back, we also tried like the config, like the default config, sample config here. They only configure it like this. They don't configure like the chain count, whatever. So we also tried that first, but no luck there either. Okay, so it's not the LED. I mean, it could still be the LDs. Like, I mean, potentially the LD chain we built here is also defective. That's possible. I mean, from what I can see here, like the board works. Unless there's a problem, because like, of course, like for the data line here, right? Like you have to have like some communication, so it's like I/O basically. Potentially the output pin can't switch fast enough or something. I don't know, like some weird stuff. I don't think I can test it. But yeah, we have power, the I/O pin works. I mean, the only thing that would be possible, right, is that something's wrong with this board here. But I don't see anything obviously wrong there. Like this all looks fine. I don't think something's wrong here either. So I really don't know. It seems like all the like individual parts work, but somehow when you put them together, they don't. Not quite sure what else we can try, to be honest. We could directly connect the LEDs to this. I mean, that's possible. And we can rule out the daughter board. But again, like there's like really not a lot of stuff on here that can break. And again, like this LED could also be defective, so we can also try to like remove this one, solder one over. It's also like it's all things that like would be quite unlikely that like two LEDs are broken. I don't know. I have no idea what to test here next. It's most likely something super obvious. Let's just... I don't know, maybe we just have to accept that we don't have toolhead LEDs anymore. We could try to power the LEDs from some other source. That's one thing we can still try. If we like verify that the LEDs itself are working. I have this board here, which has a NeoPixel connector. Let's maybe give that a shot. This should be flashed with Clipper anyways. I do have... should have a cable. I do have a cable for that. Only problem is we quickly have to open the electronics bay. Yeah, let's quickly just flip it over. And let's quickly open this bad boy up. I didn't expect that we take this long to fix LEDs. Just leave this on the side. And I'm not sure if we have to power the board with 24 volts. for the LEDs to work. Let's just first try without. And we also quickly need to check the pin out of those. So this is a SKR Mini E3V2. So it's 5 volt is on the outside. Let's actually quickly unplug that, and we can just plug in the connector we made. Okay, and then let's just add this to our clipper setup. There, if we now go to the config, we check for it's such a cool feature that you now have this here. Let's see. So we have 103XE. We have 2. 17743 is this one, and then this one is the new one. This one. Let's just add MCU V2. Grab the serial here. And just add this as an MCU. And then we just need to check this is PA8. The control pin is PA8. So in our devices, we can now say that this board is V2 PA8. Let's see. The ones we connected now are not what we have configured, because like we configured GBRW, and these don't have white, so most likely it doesn't show the correct color. It doesn't show the correct color, but we have LEDs working. So that works. There must be something. Let's try the following. Let's use the PON cable wires and wire this directly to the plug of the toolhead board. Let's carefully unplug the USB here, and then clipper will go haywire. How can you take my MCU away? Let's quickly remove this from the clipper config again. But yeah, like this is like a half broken board. The steppers are a little bit fried and everything. But like for testing stuff like this, it's really cool because like if you short something out on this board, like it's not as tragic. Let's put it like that. Okay, and then I quickly have to grab other bond wires. Let's close this up here. I was really curious. Something must be broken because like we also know now that that the config is correct, because the config, like, yes, the colors are incorrect, but it's just because we have the wrong type configured. But the LEDs are working. And it's also like such a simple config that I'm not quite sure what we could have done wrong there. But still good to know. Good to know that it's not the config. Tighten this. Okay. Let's make Clipper happy. So devices, we change the spec. And in the main printer config, we remove our V2. I'll actually just comment it out for now. And then this should all be happy again. Okay. Then yeah, let's just try to bypass the front board, but it's like I think it's the last thing we can try, right? Because these LEDs are known working. So if we now wire them up directly to the PCB and they don't work, then something with the toolhead board is not okay. So okay, let me quickly grab different DuPont wires. Right back. Okay, we have DuPont wires. Let's actually quickly shut this down again. Okay. Then let's wire our DuPont wires. I hope this kind of fits on the connector. So we know this one is ground. Let's use white for 5 volts. It's 1, 2, 3, 4 is 5 volts. Let's check the pin out again. I'm not sure what's the difference between those two. Oh, one is the front. No? I have no clue. Like even the file name looks the same, but okay. And then GPL16 is the third from the bottom. Just to confirm, we have ground, 1, 2, 3. 2, 3, and then we have the 5 volt. And then let's use the purple one. Now just to see if this fits. Also want to break the connector, of course. Okay, that just seems to work. Then black is ground. So black is ground. And white is 5 volt power. And then we have yellow, which is purple. if I get the purple plug in between. Cool. Double track. Yeah, that looks okay. So this should give us LEDs. I'm always nervous turning on such Frankenstein monsters. No smoke, that's good. Let's see. Still loading. Here we go. There's a green LED. It works. This is the default state I set when booting up. Green LED. It's like a sign of hope. I mean, let's just try what happens if I now set like some color. Yeah, exactly. It's the same problem because it's misconfigured. We now have like wrong colors. But we have LEDs. Let's quickly just like, for the fun of it, do the following. If I just quickly change it from GBRW to GRB, I think we should have correct colors. Yeah, now we have correct colors. So that works. Okay. Let's try the LEDs in the toolhead. To do so, let's first undo the config change I just did. So we go back to GRBW. And let's just quickly shut it down, turn off the power. Let's be proper. Just try to transfer that directly. So black is black, purple is yellow, and white is red. Yeah. So if now we get a green LED in the center, it's the daughter board. Still booting up. I mean, I kind of enjoy troubleshooting like that. It's kind of like fun if you at least at the end figure out what's wrong. Yeah, green LED in the center. The colors are incorrect. Didn't I change it back? No, but I mean, could also, the colors being incorrect could also be a data transmission issue. like if the connection isn't good on the data line and like the data transmission doesn't work properly, you get off like all kind of weird colors. Let's quickly see, but I'm pretty sure these are with the white. Yeah, it's also not better. Yeah. Okay, so potentially the DuPont wire doesn't really play nice here. But they turn on, so it's definitely working. It's definitely working. Okay, so then let's just double check the board. Maybe we can measure some stuff here and just see if we find where the problem lies. Let's just quickly shut this off again. Interesting. Okay, let's do some multimeter fun. Problem is I have no clue about electronics. So we know the problem is the center pin here. So let's see. I guess this is connected with something here. Sorry, I tried to lean back. Paperclip check continuity from that third pin to the leg. Which leg should it be connected to? That's my problem. Sorry, it's like it's really small. I have to lean forward to see what I'm doing. Okay, so the center pin here is connected to the, I think it's a resistor here on the front. Yeah, there I have continuity to this one here. I'm not quite sure if I should have continuity across that though. So there's 100 ohms across that, so I assume that's just a 100 ohm resistor. Then from this side of the resistor, I assume it just goes to the leg of this component here. I mean, maybe we have a schematic for that actually. To pond into the plug and then check from there to the RGB leg. Yeah, but so I'm not quite sure. Like, if there's a resistor in the middle, I don't think we can like do a continuity check. But we can do what you suggest. So it should be the, let me think, it should be this one. Oh, I don't have the DuPont cable to go in there. Because it's like these are like not the normal size DuPonts, they're like the super small ones. Let me see if there's something in the box we can use. No, they don't have a. They don't have something to crimp here. No. Let's quickly see if we can just get a cable. When this cable goes in, I just hope it makes some form of connection somewhere. Let's see. I mean, there's a path actually here on the PCB, which goes to the other resistor. So yeah, I have continuity. So here I have continuity. So from the plug here to this resistor, I have continuity. So the thing is, like, I have two resistors here, and there's like this, I don't know what kind of like component this is, like this here. But we have continuity from here, from the end, from this end of the plug to this resistor, and from this plug to this resistor. Which then leads me. Let's also quickly check what the resistance is across these two. And this is 10 kilo ohms. So we have 100 ohm, 100 ohm, and 10 kilo ohm. So these two resistors must be connected to like this component here somehow. Let's see, do we have like electrical schematic or something? We do. Oh, look at this. I have no clue on what I'm doing here, but this is exactly what we're looking at. This is the 10 kilo ohm, which comes from the plug. One side of the resistor goes to ground, seemingly. And then we have this component here with 3 legs on one side and 2 legs on the other side. That should mean that one side of the resistor goes to the center leg. Let's quickly check this. Yeah, that's connected to the center leg. So that's fine. It used to be before I pulled it out. Yeah, exactly. So basically this pin here is connected to the center leg of this component here and to the top of the resistor. That means the bottom of the resistor should be connected to ground exactly, and for this resistor the other side of the resistor should be connected to this pin here, which is the opposite side. Yeah, exactly. So these two are connected. But it most likely means that this component is broken. because like the resistors have the resistance as on the sheet, right? Because this one here that is connected to pin 4 of that thing is like 100 ohm, we said. I'm not sure what it's measuring now, but this was 100 exactly, and the other one has 10k. So like the resist, I mean that's what's on the sheet, so it's fine. We do have continuity between the parts that should have continuity, right? So from the pin where like the green thingy is in here, we have continuity to the 10k resistor and to the center pin of that component. We have continuity from the other side of the resistor to ground. And from the 100 ohm resistor, let's quickly check, we should get continuity to 5 volts. It's a bit difficult to measure. Oh, we don't have continuity here, I think. Oh, I was measuring the wrong side. It should be this side. Oh yeah, sorry, I misread. Yes, we should have from here to here, and the other side, yeah, okay. So those resistors are correctly connected. Then we can check that this pin here is connected to 5 volts. Should be this one. That is connected. And we can check that the ground pin is connected, which is also the case. Yeah, so there seemingly is also like a capacitor in there. I assume that's the part here at the back. That should go to this this like here then. Yeah, and then the other side should go to 5 volts. Which is also the case. Just no continuity to the 5 volt pin here of the RGB, but like, oh no. Oh yeah, oh, it's connected to ground. I was incorrectly. Yeah, that should go to ground. And then this like here also should, yeah, okay. That's just the voltage divider, I think, to pull down the input power. So yeah, so that should be fine. And we can check the capacitance maybe? I'm not quite sure. Yeah, that's 0.60 farad. So all the components seem to be okay. We have connections between all the components. So I assume this part is busted. I'm not quite sure what this part actually does. Could be like a logic level shift or something. SN74, SN74L, SN74L, S47N, VC1G17, VC1G17. Oh, it's a buffer with Schmidt trigger inputs. So this part is broken, and we have this package here. The question is, like, technically I could order that and we can try to replace it. Because I'm fairly certain that this is the problem. Everything else is in order. The question is, do we need that really? Because we know, like, we can just drive the LEDs directly, right? Is it one of those like parts that is like expensible? So what would happen if we directly connect this RG, like the center data pin here from this plug with the pin 16? If we just connect this directly and we just bypass this entire shizzle here. Man, it would be so easy if we would have like, if I would have a cable with this plug that we can like plug it in and then like measure basically. I wonder if we can run a jumper cable. Because what we could do, because on the back the solder points are exposed, right? So if we just run a jumper cable from the GPIO pin 16, we can try that, right? So we can use the pond wires. We can use the pond wires to grab the ground and the 5-volt signal from here. And did I not do it correctly? Yeah, so white is 5-volt. Right, we can do that. And now, if we take blue, whatever, and we just solve this as a jumper wire. Because again, like, we know the LEDs work, but we didn't have the correct colors, right? We had color issues here. So potentially this is not like a proper fix. Proper, like, I mean, most likely this electronics part, the buffer does something. I assume they don't put it there for funds. I don't know if this is like stupid to do. Not sure if you can short something or somehow. Because like the component is still there, I'm just not sure if it does anything. Because worst case, if I do that, I'll break the toolhead board in some way, which I preferably would not. Question is also like, I mean, yeah, let's not do that. I don't know what the effect is there. To be honest, I think I would just ask on the Voron Discord if somebody has like a good idea. Somebody watching of the two people knows, let me know. But I think like otherwise I would try to like order this part because we know the part number from the schematic. I have plugs. I want to buy like a hot air station for some time. I think that's a good excuse to do so. And then we just unsolder this part and attempt to resolder it. I mean, like worst case, we break the RGB LD, which is already the case. So doesn't seem like there's much to lose in this situation. So let's just, we found exactly where the problem is. And then I think let's really just go for replacing this component. You can buy this board on its own. Can I buy this board on its own? Let me quickly check that. But to be honest, even if I can buy this board on its own, like I would be very tempted to try to fix this one. But then like if it breaks, you know. I at least can buy a new one. So we need a SB2209. Not sure if I find it like this. Yeah, I can buy this. This is only the front board. That doesn't seem to be like a horrible deal, to be honest. And there's no soldering involved, like we have to replace it. Let's also quickly check if you can. I don't want to order like those parts. Usually I have to order DigiKey and stuff like that. Yeah. I think that's a good investment. Let me order a bit of like 20 of those parts. Yeah, so that's the correct package and everything. So let's just order 20 of those and try to solder the part on there. Unsoldering will be the challenge, to be honest. But I'm pretty sure we can make it work. Does AliExpress also sell me something like this, like a very small, tiny one? Doesn't need to be good, I guess. Maybe not the one for €1.73. I'll check. Everyone wants to buy something like this, like for some time. Just like it needs to be really delicate. So I'll look into that, and then I ordered this one, and I think I'm not ordering the replacement board yet. I'm really intrigued to like try to replace it one component and see it working. That would be really cool. Cool, but then let's call this a win. We figured out the problem, and let's do some fun stuff. But I really wonder like how it broke, because like I must have broken it because it worked. I saw, and I'm really certain I saw the LEDs working. I have video proof most likely. So something I did killed it. Potentially it was that like I misplaced the tool head and it didn't work. Maybe, not sure. Yeah. I'll also ask on the Voron Discord if somebody knows if I can bypass this buffer. What the effect would be if I do that. Because if I can just bypass it with a jumper cable, it would also be like a viable solution, I guess. Cool. Good. Then close this all up. I'm happy we found the problem. Like that, then at least like we know pretty much what component is the problem. Yes, so works. Cool. Then, what else can we do or should we do? So yeah, basically status quo. This is the first print I did. Just a quick Voron cube. This was printed relatively fast at 5,000 millimeters second squared. But yeah, it doesn't look pretty, right? So first, the overhangs are complete horrible, and I think that just has to do with the cooling fan being really weak. Like I just feel like it doesn't push a lot of air. So in combination with like fast printing speeds, this most likely just is too much. Which is fine. I can ignore the overhangs for now. But what really bothers me is we have really inconsistent extrusion here. Like you just see like it's not like well stacked in a certain way. I'm not quite sure if this is an extruder issue or if this has to do with some mechanical issue. What I would do, the problem is also like on the, it kind of looks like similar on all sides. Like it's not like that's like one side has the issue more than others. They all look about the same. Like here, I think you see it a bit less because there's less like surface. You could say X has it a bit more, but I think it's just like a bit of an illusion. So I think this can be like one of two things. Either like an extrusion issue, which could very well be because we have a brand new extruder, so potentially there's something wrong there. Or it's like just like some mechanical issue, for example, like the hotend not being like properly tightened. But I think that's okay. Like if I pull on the hotend, like the entire like tool head basically moves. I mean, there's maybe a bit of play. Now also there, like the entire tool head moves basically. Just the hotend moves a tiny bit more. Yeah, let's actually quickly just check whether this is proper tightened. We could have done that before tightening this again, but you know, where's the fun if you can't like unscrew something 15 times? Let's just make sure that everything is nice and tight here. And then I think the best thing to do would be to print something that print something slower And maybe we can just print something that is like long and skinny in a certain way. Let's see, can we get this? Why is this not coming off? What do I miss? Is the cable too short? Oh, there's filaments. Okay, here we go. Well, that explains it. Yeah, I don't think I get this out now. Okay, I can still tighten the... Yeah, I mean, they were pretty tight, not 1000%, but I don't think that was the issue. Sure this is correctly on. Okay. Let's just do a quick test print and see if we can... Yeah, I don't think anything changed there. I feel like there's a tiny bit of movement, but I'm sure if this... Yeah, there's a bit of movement. Yeah. So if I push this, I mean, it's a bit dark, but if I push this, like it's not much for the unfocused nature here, but like if I push this like tiny bit over here, like it's just like left right. And I can feel it like clicking basically, a little bit. So I can wiggle this a bit and the toolhead doesn't wiggle in the same way. So our... But then it should be worse in Y. If this is the problem, because like it's like the cube is printed like this, right? And the movement I feel is mostly left-right. I mean, it's for sure not good, but I don't think that's the issue we're seeing here on the test tube. We add a cube here. Yeah, then it would show up in Y. If this would be the issue, it would show up on the Y side. And if anything, the Y side is better. Okay, let's do the following. Let's just quickly check the print tuning guide. And see if we can find something that kind of matches our problem. Let's see. So yeah, I don't think we have extruder skipping per se. There's also no pattern to it. I mean, it's a very small print, so potentially it has something like this. First layer is fine, layer shifting we don't have. We also don't have that. Bookmarks we don't have. No. So it could be something like this could be. That we have a backlash issue. But it's also like it's showing up like on straight lines. So I think if it would be a backlash issue, we would have more around the corners. And the corners are not great, don't get me wrong, but let's do the following. Let's just print like a Voron cube at lower speed, because I printed it quite fast because my goal was like to figure out if we can kind of like sustain, like the motors can sustain the speeds. So let's just print a cube at 2000 millimeters squared. And to make it print faster, let's print half of it. Like we know on the X side we have more problems. So let's split this model. And we just print half of it. Let's see if that goes well. First time I print like really a half Voron cube. But yeah, this is the phase that has the most inconsistencies. So it should take 20 minutes. And I have like this like almost empty spool here that should just be enough for like for our test print. Maybe we should close the extruder. That would make a lot of sense. Let's see. Just have to pay attention that we really print slower, but like it's set the acceleration to 2000 already, so it looks good. And we still also have to install the adaptive bed leveling at some point. Totally forgot about that. It always takes quite a while to build up the bed mesh. If I can skip that a bit, that would be very nice. Here we go. Would be much nicer with toolhead lights for sure. Hi, Ironic. Just in time for small test sprints. Yes, I haven't seen you in a while. Welcome back. Not sure if you missed too much. Like we just installed toolhead board. What else did we do? We installed toolhead board. That's mostly what we did. We now have a direct drive extruder, so we have a Clockwork 2, and that was pretty much last stream. So it was not the most straightforward process actually. And now we're still having issues with the toolhead LEDs not working. So we're like troubleshooting that and figured out there's a broken electronics component on the front part of the tool board. So I have to order replacement, and then I'll try to replace the part. But yeah, now we're just trying to like improve the print a bit because the quality is not quite there yet. It's like the test cube I printed this week. So it's pretty well freeze. I saw like I didn't properly close the lid here. School's finally over, so I have time on Friday to watch now. Congratulations on school over. Your stream would be during school. Yeah, like I think the time zone difference is quite large, right? Because for me it's now 9 p.m. But yeah, this will take like, what does it say, like 20-ish minutes, I think, to print. 2 p.m. right now. 7 hours, yeah. Quite a bit. Yeah. Let's see. Not quite sure if we can do something like in parallel. Maybe we can quickly check out adaptive bed meshing. How that works, because I have actually never looked into how adaptive bed meshing works. Like I know you have to clone some Git or something. Adaptive bed mesh. Nope. Let's not miss the start. Yeah, the Z offset is still like horribly off. Trying my best. Yeah, but I guess we can like let it be. Printing its half Voron cube here. So let's just see, maybe we can do that not inside because we have to restart clipper for sure. Campus in clipper now. Latest version of clipper. We updated clipper, so add adaptive 1 after any time you call bad mesh calibrate, and you can comment out camp adaptive bad mesh line in clipper camp. Oh, well that makes, oh, that's not what I wanted. That makes it easy. Clipper bad mesh adaptive. Oh. Adaptive meshes. Totally missed that. Adaptive bad meshing is a way to speed up the bad meshing. Oh, so we just say adaptive margin 5. That's pretty easy. Margin millimeter at around the area to be used by the defined object. The diagram below shows. Okay, so basically it just takes the objects, adds a margin around it. Cool. So they use the G-code objects defined in the G-code file, which we already have. That's good. So basically we have to say adaptive 1 also in the G-code. I'm actually not quite sure how I set this up. I think it's part of the start G-code. Print start, bad mesh calibrate, exactly. And we already have this area start, area end thing. Because I remember like I had at some point something set up similar to adaptive bad meshing. I had something similar set up, and I think this is where I copied this like area start, area end, and so we can definitely remove that. And I'm pretty sure it's not helpful at all. So we can remove this, and then we most likely just say adaptive equals 1, right? If I read this correctly. And then adaptive margin, I would just add to the config. I think that makes the most sense. So it's possible mesh min, mesh max, exactly, that's what we did. And then probe count also comes from the config, I assume. So if we just do this, that should be technically all we need. And then we also need to where did you find the BLTouch? I broke my clipper config in like a lot of different bad mesh. So here we just say adaptive margin is 5. I would just go with what they suggest. So adaptive margin 5. Yeah. Cool. So I guess that's it already. That was pretty easy. If it works. Yeah, it looks similarly horrible. I can already tell you that. Not sure if it like it doesn't look good. So I mean now it's relatively slow, right? Like it's not like a super fast print. So I would say let's give this like another couple minutes. Maybe let's print half the cube from height and it should be fine, right? Just get like a... Oh yeah, you can also somewhat see it on the camera from the back. It's like not really like even. Then I think we should check the extruder. That would be my next guess. That the extruder is not like extruding nicely. So we did check the troubleshooting section here. And I mean, what we see could be bulging. And it could also be the extrusion patterns. But that would be quite a... The thing is, because like surface is relatively small, I don't think you would see it like nicely as this. So maybe it's worth after this just printing like some test print with like a large surface to get like a better picture of it. So external parameters first. And we can try that, but I'm not sure if this... I mean, this looks... This looks somewhat like what I see here on this cube. It's just like even more inconsistent. So potentially we can try the setting. And yeah, it's just way worse for bridging. Like you see, the bridge here is like way worse. Reduce parameter acceleration. But we're now like already quite slow on acceleration in general, so that should not be wrong. We also don't have it on the STL vertices, and we don't have it around features necessarily, I think. But yeah, also like pressure advance could be off. Like I did a very basic pressure advance tuning, so maybe it's worth doing that. Let's see. I think we kind of have like half the cube now, so let's just leave it here for now and just see what it's doing. I'll also do the firmware restart now, so we get our adaptive mesh. Let's take a look at this. Yep. Camera is doing a little bit. So just comparing it to the previous one. It's interesting, it's in different spots, I think. Like here's just like really weird extrusion. And this looks about the same, like there's like this same line here. So I said it kind of looks the same, like here on the side. It's interesting, like here, this line at least is definitely on the bottom side of the Voron logo. And that's not a problem we had on this cube. Like this cube doesn't have this. Not quite sure if this is really like helpful. Yeah, and the first layer is Have to fix that. I'm not sure what I should do with this now. I mean, let's try first the parameters. And maybe let's also try to print like something with like a larger surface area. So we just add a rectangle. Cube. So we need to have it quite wide. Let's just, I don't know. In X, let's just do 50. And in Y, let's just do 3. It's very, very narrow. And then let's just print it like 15 high. And so we print it a tiny bit higher. I'm not changing settings yet. I'm not changing settings yet. Let's just see how this prints out. But now we should have adaptive meshing, right? If it worked. Let's see. Bed needs to heat a bit. Let me also already just put that fair bit down, because we know it's like way too high up. So I put it now down 0.07, which is quite a almost half a layer. But I think we need that. Yeah, it's interesting. Like this line goes completely around, like also on the inside, and it's exactly like where the overhang ends from this like slope here on the bottom. No, I don't think adaptive meshing works. See, did we miss something here? Adaptive. We set adaptive margin. Yeah, just default. We set adaptive to 1. Maybe I don't have the latest clipper. But I updated to. Oh, I can't check for updates while printing. But I have 0.12. Adaptive. It's not mentioned here. Interesting. bad. Oops. That's quite old. No, it's not mentioned in the change log. It also doesn't say here in the documentation like it was added in version XYZ. Flipper, match, calibrate. I'm looking for the documentation with the G codes. Bad mesh calibrate. Yeah, already it doesn't look like it's extruding properly. Let's give this a second. Now, also here it's described with adaptive, but it doesn't say like what clipper version it says. Hi there, Big City Tours. Let's see. Yes, it's not really like the best prints to film. Let's see. I don't think this will take like more than like 5 minutes to print. 12 minutes. Okay, let's see. Maybe we don't print the entire HUD. There's at least already one like of those like under-extruded layers. I'm not quite sure what this could be. Okay. While it's printing, let's quickly like look a little bit more in the adaptive bad meshing situation. Adaptive 1, after any time you call bad mesh calibrate. And you can comment out the camp. Yeah, that's what you did, right? But it doesn't really say like which clipper version supports that. But I assume like I'm on the latest, so it should be in there. And it also did not complain about the adaptive margin. If this would be incorrect, like if it wouldn't know what adaptive margin is, it would complain that it doesn't expect that key in the section. So that should be fine. Which leaves us then with the print start. And there's like the question. If we need any other other things here besides adaptive one. Adaptive. Did I misspell that? No, adaptive equals 1. That's fine. Let me see, do it. You know, it's also only place where I call this. I don't think there's anything I'm missing. Yes, we also have exclude object. But we did not check the logs in the console. No, directly went to probing, probe. That mesh level complete. And does not look good. Is it this crooked? It's like so bad you should see it by eye, right? It's like 1 millimeter. Minus 0.6 to like 0.5. It's like 1 millimeter front to back. I think you can actually see it, yeah. Okay, that's maybe something to improve, but should be fine for now. Yeah, we have exclude object set up because I can cancel the object here, so that's okay. Like it says Q, but it has the object. I can cancel the object. Oh yeah, now you see on the. I think there's another one of those like bad layers. Yeah, let's print like a little bit more, so we have like a bit more like sample height. Now it seems like it's completely ignored the adaptive equals 1. Yeah, I mean this one I have for sure. Do I have to say profile adaptive one? Add the bad mesh calibrate to your start G-code macro, so it's part of the printed G-code. Yeah, that's what we have. And that's bad mesh calibrate profile adaptive one. I mean, we can try this one. Do you have label object turned on in the slides? Yeah, I use the exclude object all the time. So you also see here it has the object label, and I can cancel the object. So this is fine. So it must be something with the way how I call the bad mesh calibrate. I mean, we can try this profile adaptive. Maybe that's something I just miss. I don't think it's described here. I mean, if I search for adaptive, just says adaptive specified, then the objects defined by G-code. Option adaptive value overrides adaptive margin. Yeah, we have to configure. But it doesn't specify that we have to name the profile adaptive. But let's try. Yeah. And the other thing we actually could try also is like just to try a different filament, to be honest. it's like the rests. I just want to use like little rests of white filament to calibrate that, but maybe it's not good. I doubt that's the problem, but we can try. Okay, let's try the cancel object. And now I should basically just be done. Yeah. Oh, that was that was tight. Let's take a look at this. So it's interesting because it seems cyclical. Sorry, I'm not showing this to you. So I see 3 bad layers, and it's a bit hard to see maybe. Let me. Yeah, like this. I have 3 bad layers, right? I have 1 layer here, 1 layer here, and 1 layer here. And what I notice is that the distance between the 2 bad layers, I mean they're all like not perfect. Don't get me wrong here, but like the distance between the really bad ones is exactly the same. And they go like 360 degrees around. So you see it here quite clear. So it would focus, it would be even better. So this is exactly the same distance, which is like luckily exactly 1 tweezer distance. So whatever the problem is, it's like something cyclical. So it's definitely, I mean, this is like an extruder issue anyways, I'm pretty sure. The interesting part is on this side it's kind of bulging out a bit, and here it's going in. So maybe it's also something tad mechanical, I don't know. Huh, not quite sure what to make of that. But before the bed cools down, let's just I just quickly print the same. Let's quickly add the macro with the adaptive thing. Kind of like try this in parallel. The macros. Okay, so I just copied that from the discussion in the Clipper forum. Let's just quickly see if I print it again, if it still matches the entire bed or if it's now fine. Okay, so then regarding this print. I mean, the other layers are kind of okay, to be honest. There's some other problems, but like besides these like really bad like layers, the rest looks kind of okay. But it looks a bit like this, just not as pretty. Just not as pretty. So maybe it's even worth like printing an even larger object with like less shells, like just like a hollow object, to just get a better feel of that. No, it's still meshing the entire thing. So it just ignores the adaptive mesh. Let's just quickly kill that. Hey, Tinga. see. Oh, and like since the last Moonraker or Flipper, I don't know, like I update everything on the same time, which is always smart. Like this button is broken sometimes. You have to go through the menu. Oh no, the menu also doesn't work anymore. Reboot works. Let's wait for it to reboot. But it's curious because I do the exact same thing and it's not meshing adaptively. And this documentation is not really helpful in a certain sense. Like yes, it explains perfectly what it's doing. But nothing else, so it's not really helpful. Flipper native adaptive mesh example. It's all pointing the same documentation. Yeah, and we've also found that there's no mention in the changelog. We can watch a video and educate us this way, but yeah, okay. I feel like it's something I need to look into a bit. Too bad. I hope we can just enable it on the fly, but yep. See, at least like the firmware restart works again. Let's quickly slice. I mean, I already like preheat the bed again. I don't waste time. Let's quickly just slice like a cube, a bigger, like normal sized cube. And let's just make this relatively large. I don't know, like 50 like this. But let's just print it basically hollow. So let's just say top shell, we don't want a top shell, and wall, let's just do 2 wall loops. And infill is 0. And we just have like a cube. On bottom, let's do 1. Let's do 2. So we just have this like hollow thing, which should allow us to see quite well like what's going on. Okay, let's. Oh, you didn't see anything in the. Was the screen just black? Ah. Still no adaptive bed meshing. Nearly. The camera mount is a bit loose. Let me fix it quickly. Okay. Now I'm happy again. Okay, so we already figured out it's something that is rhythmic. Maybe we can also check if there's like somebody who made a list with like rhythmic extruder issue, not intermittent. I'm not sure. Maybe I'm just not quite using the right word here. Let's see. Okay. It's just weird because the other layers look fine. It's just like every centimeter in this like small test print, like it's just like completely screwing up. And there's like no like noise that it makes or something, so it's just not really extruding properly. Okay, let's see. Almost there with the temperature. Oh, but also here in the logs, like seeing it now, like it says bed mesh has been set to profile default. But didn't we specify? Yeah, we said profile adaptive. Makes me wonder if it ignores this like bed mesh calibrate here and just pulls it from somewhere else. Because it now ignores the adaptive one and it also ignores the profile adaptive. So it's kind of like ignoring everything. Oh wait, I didn't save the Z offset. That also is really off. Look at this. Let me quickly show you like once now it's extruding like way less. There's like one spot in the center where it just extrudes like way less. So if you look at this, they're just, I mean, like the offset is horrible, ignore that. But you see here in the center, like it just stopped extruding, like almost completely. Like here and here it's off, but it's consistent. And then you see here, here, and like the big one in the center just like extruded way less. So I think there's just like inconsistency in the extrusion. So maybe that's like more like a keyword we can Google, like inconsistent extrusion. Or temporary under extrusion. Problems after retraction or layer changes doesn't really apply because like in our like other print it was like, I mean, every layer was the same, so it only was like every other. And we can check the backlash of the extruder. Mm. Okay, so basically he says retraction is something that worked for him. And I actually found like that I have really weird settings, partially because I had Poland set up before. But I think I fixed all the settings, like retraction. I put an Orca now to 0.4, which should be fine. I don't think that's it. We can do a pit auto tune, but nothing really changed there. We can also try to add a bit more pressure on the filament. Quickly. So if we, I mean the filament is in well, but we can just try to increase the tension a bit. Yeah, but now it just wants to jump open. Yeah, okay. Well, that's that doesn't help. Don't knock your print at your pins. Serious prints. I'm just trying to like see if it jumps open on its own. I mean, it's really easy for it to open, but like the filament is quite well in. So basically, like when the latch is closed, oh, well, no, not anymore. What did I do now? Now it's properly gripped. See if I tighten the spring here a bit more. Yeah, okay, so if I tighten the spring, yeah, it jumps open on its own. Maybe the printed latch isn't good. It's like barely holding. Now we have like very low tension or like pressure on the filament. Yeah, let's try. Yeah, we might have like a tiny bit of under extrusion on the spot, but yeah, let's just let this print for like a couple minutes. Then we get like a little bit of like kite. But yeah, like the latch isn't quite, like it's not like super close. So I wonder if it's at least part of the problem that like the mechanics are just not properly done. We just have to disregard like the bottom 5 layers because I just really screwed around with the printhead now. I think like if we still have the problem, should show up around now. So far it kind of looks good, except the bottom layers, which we know are known not good. Yeah, but now it looks fine. Aha! Now we have a problem. If you look at it from the side, you see like there's now like one layer that's like way thicker. So there's our problem. So the question now is, do we have like another one of those showing up in the same distance? It's a bit different. So I'm just checking if like for this print, if we have it on the same Z height. That would then indicate that we have some problem with the mechanics at that height, but it's a bit different. Okay, but then we need to print at least to this height. That we have like good comparison. It's like the Y motor is so loud compared to the other two. I'm not sure if you can hear it on stream actually, but like the Y motor makes like 3 times the noise of like left right. So every time it like moves like left right, it's like very like pleasant, nice sound. And like the Y just makes like a horrible noise. If it would be like in the same rhythm, in like a couple layers, we should see like a next line. Potentially a bit more because we also have the bottom layers, right? We have like 2 bottom layers that could like throw it off a bit. Oh, but yeah, there it is. There's the second one. Let's give it like 3-4 layers more. Actually, like let's print one more of those of those faulty layers, because then we can really compare if the distance is the same or not. You also have like barely filament left. But yeah, like afterwards, let's do maybe just this print again, like this one, the very small one, and let's just use different filament and see if like because like technically it could also be just like bad filament, and I haven't printed this filament in quite some time. And maybe it's just not up to scratch anymore. I don't know. It doesn't look like filament issue, but okay. Should be, yeah, a couple layers more. Okay, so now we should get another faulty layer. Now the print's almost over. Yep, I think there we are. Okay, so whatever the problem causes, we need to find something that has like quite a long like period between like the whatever repeats. Okay, it's like 10 seconds and print's over. Oh no, wait, there was a slicer estimate. Okay, let's just do like I don't know, like 3-4 layers more, and then we can cancel it, I think. Oh yeah, okay. Now the estimate of Clipper is also 50 seconds, so let's just finish it. Okay, so yeah, just let's cancel. No need to wait. Okay, so the first layer is obviously horrific. There's we don't have to discuss that. That is not good, not nice, but besides the point for now. So yeah, it's a bit different. Like if you see the difference, the gap here. Like it doesn't quite line up. It's like a couple of layers different height. So basically this means that it's not something with that. So it must be something with the extruder. But it repeats perfectly. Like these two and these two are the exact same distance, so it's like something periodical. And it's also like interesting, right? Like I didn't pay attention now in which direction I pulled it off. I think in this direction, but yeah, this is where we stopped. Because like here you see like it's I wonder it's shifting. because like here, like on the inside, kind of hard to show. Do we want to focus here? Here's like a gap, like it's a gap, but on the outside it bulges out. And here's a gap. Is it bulging? Yeah, there's a gap outside. Outside is a gap, and then inside you have a bulge. And here you have a gap inside, and outside you have a bulge. So it seems like it's shifted down and over. But then that means it's not an extruder issue. Also here you have a gap inside and bulge outside. Minimal bulge outside, minimal gap inside. And you have gap, bulge, bulge, gap. That means we need to look at the AV motors most likely. Because if it would be an extruder issue, it would be like either like it would have a gap inside and outside, or a bulge inside and outside. But because we have a bulge on one side and a gap on the other, it must be shifted. Also, like if it would be like a Z issue, that like you have inconsistent Z movement, you would have the same. Like it would either be like a gap on both or bulge on both. So this is like a position problem. It's just like completely like repeatable in Z, which is interesting. I'm not sure if this makes sense what I'm doing now, but like if I hold this, like I don't see like stepping necessarily. Like it doesn't step over. Well, at least I have a box now. Yeah, I'm not sure what to do there. Because like it's something that's basically happening for like, let's say like 2 layers, and then it fixes itself again. We also have VFA quite a bit, but that's like, I guess later problem. I mean like the extrusion in between those weird layers looks quite okay, to be honest. Like it's not perfect, but like in this area in between those like bad ones, I would say it's acceptable. Let's quickly try the different filament, just for fun. I don't think it makes any difference, but I've seen weirder things, so. Quickly try that, and then let's see what we learn. Oh. I accidentally set 200 degrees to the bed. Oh, no. That broke. This filament is really brittle. Let me just move it down to 50. I'm not sure if I now made it clock. No. This is okay. I don't know, but this filament seems horrible. I don't think this is that old. Okay. Let's just try to print the same thing again. Same box. And let's see what happens. Oh yeah, and again, like it said, like safe profile. Oh, I'm looking at old logs. Yeah, it's not doing the adaptive meshing. I just wonder, like, we didn't change anything on the we didn't change anything like on the mechanical parts necessarily. So I wonder why we now would suddenly have like issues with the mechanical movement. The only thing we changed, of course, is the motors. But it would be weird for the motors to cause such an issue, I think. Especially because it's like completely like rhythmic. Yeah, it says again save to profile default. So I think it just ignores my print start macro somehow. Really weird. I'm really curious to see if like the filament makes any difference. Start any second now. I mean, a pit tune I think would be also in order at some point. Like it's not like once it has temperature, it's really straight. Looking at the graph in Moonraker Mesa, but it overshoots quite a bit like when it preheats. There you go. I mean, the Z offset at least looks a bit better now. It's still quite high. Okay. Let's see about that. Yeah, but this is so funny. It's completely reproducible. It now gets better. It looks different from pattern than the last one. Let's see. Yeah, but I mean technically we don't even have to print like further. Yeah, that is too messed up a first layer. Yeah, well, that did not work out, but still, like, I think like looking at this, I mean, let's just try again. And I just put it down like a bit more. Because like it's, I mean, in the corner, it's kind of okay, but it's like, can it be that off? Yeah. Okay, let's do the following. I will take a closer look on the test prints we made with the white filament, and I'll just like ask around a bit, because like this is like really good indication here. We have this like reproducible pattern basically of shifting, and yeah, then I'll just go from there, do some more research, and hopefully fix the problem until next time, and can tell you what the problem was. Next stream, we will work on the umbilical cable. So we will remove the USB cable and complete switch to CAN bus. So we will add a CAN bus converter board under that. And then basically, yeah, use the two CAN bus cables we don't use yet and get rid of the USB cable. And then hopefully everything is fine in printing. I will also order the part for the LED that is broken, but I'm pretty sure it won't arrive by next week. So that might be for the future then that I mean, it's just a toolhead LED, so it's not really like essential. But it would be like a fun stream at some point, like trying to like fix that. Cool, okay, yeah, but I guess then not really successful stream. Like we figured out we can't fix the LEDs, and we didn't figure out the print issue, but yeah, progress is progress. Cool, then thank you everyone for tuning in, and then see you next week with hopefully more insights on what was good. Enjoy your weekend. See you next week.